I'm Madhumita from Open Forest 4D. In this video, I'm going to show you Potree Viewer and its display attributes. We'll look at how to navigate the scene panel and how to visualize the same point cloud in different ways using classification and return number. By the end of this video, you'll be able to switch between different display attributes and understand what each one tells you about the landscape. So let's get started.
In Activity 1, you'll find a link to Open Topography, which provides access to Utah State LiDAR data. Start by opening that link, and you'll be redirected to this page. Once redirected, scroll down a bit, and under Section 4, 3D Point Cloud Visualization, make sure to tick Generate 3D Point Cloud Browser Visualization. Once ticked, go down to Job Description and Notification, enter your email address, and click on Submit.
Here's the landing page of the open topography once we submit the job. I have chosen a landscape in Wasatch Front, Utah. If I go down below, I see a link to view 3D point cloud in browser. Once I click this link, I'll be redirected to a different tab. Here, I have a LiDAR point cloud loaded in Potree Viewer. You can zoom in and out using the mousepad or the touchpad on the laptop. A point to note, LiDAR doesn't contain any color by default. Right now, the points that are colored based on elevation. That means the color of each point simply represents its height. Lower points are colored in cooler tones like blue and green, and higher points, once they go towards higher elevation, shift towards warmer tones like orange and red. This is the default view, and it's a great start to understand the sense of the terrain. To change how the points are displayed, we go to the sidebar on the left. I click on the menu icon, the three lines that you see on the top left corner, and a panel appears. Go to the scene section, and if you scroll down a bit, you see display attribute subsection. Currently, it's in elevation mode, which is default. Try to change the elevation mode to classification by clicking on the drop down menu. You see classification here and see how the landscape view changes. Classification tells us what each point actually hit. During processing, every point in the LiDAR dataset gets assigned to a class code based on the type of surface it belongs to. These codes follow a standard. Class 1 is unclassified, Class 2 is ground, and Class 6 is buildings, etc. Looking at our scene, the orange points here represents the ground. The gray points represent unclassified. You can look into each of them separately by looking at the filters. In the panel, go to Filters and open it up. Currently, unclassified and ground are ticked, which means these two are the classified points present in the landscape. If you want to look into the ground points separately, you can simply untick others. And these are the points represented as ground. You can do the same with unclassified as well. And these are the unclassified points. This classification is especially useful when we generate a digital terrain model. In digital terrain model, we only use ground points. When we compute a canopy height model, we are comparing the vegetation points against that ground surface. So this attribute shows you exactly which points feed into which product.
Now, let's switch the display attribute over to return number. Go to the display attribute dropdown, change it from classification to return number. The colors you're seeing here represent different types of return. Let's start with yellow points which are prominent. These are single returns. A single return means a laser pulse hit one surface, bounced straight back, and nothing continued past it. No energy made it through anything below. So, every yellow point on this landscape came from a pulse with exactly one return. Everything else you see, all the other colors, those come from pulses that produce multiple returns. Now, let me zoom into one canopy so that we can look at it more closely. Here, you can see the yellow single returns and you can also see red points. Red always represents the first return of a multi-return pulse. Now look down near the ground. Those blue points are last returns. And the green points in between are everything that falls between first and last. Let's say we have a pulse produced 4 returns in total. The first return is red, the fourth, which is the last one, is blue. Returns 2 and 3 are both green. We can confirm all this by using the filter section. Let me open that up. Under filter section, go to returns subsection. I'm going to go with number of returns and drag both the endpoints to 4 like this. Now we are only looking at pulses that produced exactly 4 returns. Let me show you the whole landscape. Next, I'll go to return number and drag both endpoints to 1. Notice we only have red points now. Now let me drag the return number up to 4. Everything here is blue. And if I check return number 2, it's green. Same goes with return number 3 as well. So that confirms the pattern. First return is red, last return is blue, and everything in between is green. And this is the whole landscape. Now go ahead and try this yourself with other values. Set the number of returns to 2 or 3 or 5 and step through each return number and see how the colors behave.
This connects directly to the surface models. First returns gives us top of everything, which is essential for the digital surface model. So to recap, open the sidebar, go to the scene panel, and use the attribute dropdown to change how it's displayed. We look at classification, which tells us what each point hit, and return number, which tells us how the laser pulse interacted with the vegetation and other landscapes. As a next step, try exploring the intensity and RGB attributes on your own with the same workflow. Thanks for watching.